welcome everybody to GeoHug. So before we kick off today's session, I would like to take this time to acknowledge the traditional lands which we're all coming from today. I live on the beautiful lands of the Gadigal of the people of the Aurora Nation, and I'd like to pay my respects to the elders past, present, and future. And yes, I am thrilled that we have Leah Lynham with us today. So Leah is a PhD candidate at James Cook University and currently serves as the Secretary for the Australian Regolith Geoscience Scientists Alliance, and her primary research focuses on reconstructing the middle-late Eocene paleo environment of the Eastern Goldfields region. And it is going to be brilliant as we travel through time with her today as she unearths geological treasures in the Lefroy drainage system. So this is going to be a fantastic session. I hope you all enjoy it. I will be promoting you up as panelists throughout the session. If you're able to jump off mute, you're more than welcome to come on through. We can have some great discussions at the end. But yes, thank you so much, Leah, for joining. It's awesome having you here today.
Thanks for having me. I'm quite excited to talk about paleo channels a lot.
Yes, I'm very excited to hear all about it. So I really appreciate you taking the time to be here. I'm really curious what got you into geology and paleo channels and regoliths and all the things you love.
So geology, David Attenborough. When I was a kid, I watched, and it's on YouTube if anyone wants to watch it. There's a very old paleontology documentary done by the BBC and David Attenborough called Lost Worlds, Vanished Lives. And I saw that and I was immediately hooked. My aunt will regale people with stories of me building Jurassic Park with Lego and things like that. And I use string to make electric fences. But I come from a really low socioeconomic area. And it was the second you leave school, you have to go and work full time. There's no time for college or anything like that. And I absolutely exhausted myself working full-time and doing my A-levels full-time. And geology was actually an accident. I was enrolled in history, archaeology, and religious education. And I was really fed up of the religious education A-level. And there was another girl that was doing geology that was finding it too difficult, and she wanted to do religious education. So we swapped notes about 6 weeks into the first year starting. Found geology, realized that this is where fossils are, and wow, that's what I want to do. So I ended up going to uni to do that after college.
Oh, that is brilliant. Oh my gosh. And never look back, hey?
No.
So what have been some of your sort of favorite memories and joys from your career so far?
Oh. The thing that really sticks out to me is spending 5 weeks in the Spanish bush, I suppose, doing my honours coursework in the Aliaga Geopark. And I spent that 6 weeks mapping and logging some absolutely amazing road cuts and building up a paleoenvironmental history of the Aptian to Albion there. And also there was a sub basin that had lots of dinosaur trackways and things in it. And that was really amazing.
That is awesome. Wow. That would have been really special to go do.
Yeah, definitely.
Yeah. Oh my gosh, that is very cool. And I know this has been a very tough one for you, but I am curious which pet rocks you want to show us today.
So I have a couple. Well, I have 4 next to me. So the first of them is this. It's actually a rudist bivalve, and it's from that Aliaga Geopark. Rudists are heterodon bivalves. They don't look like a normal bivalve. These were reef builders during the Cretaceous. They went extinct at the end Cretaceous. And yeah, that just signifies my honours project and what really got me interested in this.
That is awesome.
I have a keel from an ammonite, the first fossil I ever found in Folkestone in the Galt Clay, when I was doing my A-levels and I was doing A-level geology. So that takes pride of place here in my office too. I have a huge chunk of coral from Cheddar Gorge in the UK. My daughter actually found this a couple of years ago when we went back for a holiday, and I was like, yoink, you're coming home with me. We all had like 30 kilos of luggage, all 5 of us, and I'm pretty sure one holdall was literally just rocks coming back from the UK. But to do with the Lefroy drainage system, I actually have a lump of ferruginized spongylite. And these are all sponge fossils that have been found, and these are completely novel to the Lefroy drainage system, and I found them completely by accident, and I will tell that story a little bit later.
Oh my gosh, that is brilliant. I love that. What a great selection you have there. And I love all the sentimental value behind them as well. So that is awesome. Well, yeah, thank you so much again for being here. And yeah, if you want to share your screen and we'll get stuck into it.
So thanks so much, Jess. So I'm going to weave a tale then of geological evolution through the Lefroy drainage, and hopefully I'll leave you wanting more. Although I'm a geologist and a paleontologist, I like to consider myself a storyteller. And I like to use all different facets of geology and paleontology and geochemistry to build up past environments and to really think about the landscape evolution. And I'd also like to recognise Naju as the traditional owners of the country that I've been working in. So we've gone through a little bit about who I am. I'm not just a LinkedIn pest that posts constantly about paleo channels. I started as a marine micropaleontologist in oil and gas. And then I moved to Australia and I got into exploration for several years. I was on maternity leave. I have 3 children and I got really, really bored on maternity leave. I live in Kambalda, so I live in a very, very small town. Was a nickel hub of Australia, now lots and lots of gold mining. And my husband's then boss, Dave Nixon, who some of you may know, contacted me one day, knew I was a paleontologist, said, "Hey, we found a block of shells in the open pit. Do you want to come and take a look?" Me being me, "You've been in the sun too long. Shells in the open pit. Aren't you all dealing with Archean gold?" No, it was a block of shells, and I'll show the picture of that later. So that snowballed, and here I am. So I am also involved in a lot of outreach work from kindy all the way through to adult level, and it's something that I really enjoy. I really enjoy bringing tangible local examples to school children and getting them involved in geology and also industry and resources. They're living in such close proximity to these resources, and they have such a they're so close to all of these resources, geological resources. They should be at the forefront, and they're often not. We often have subpar STEM education out here in the outback. So this is just a selection of some of my favorite things. This is me as an A-level student at 17 years old at the BGS, British Geological Survey in Keyworth, and we're looking at some of the original maps. That's Peak Charles. I went up there looking for a wave cut platform, realized how high that boulder was, and I'm a bit like Bambi on ice, had to get help getting down. Those are those dinosaur trackways from my honours coursework. The summit of Mount Etna, that was an amazing field trip as well. And that's just some channel architecture from what I'm working on at the moment. But we'll dive into the paleo channels and we'll do a drainage overview. If you squint and get your eye in then on this, you'll see that there are chains of salt lakes, and they are all heading off towards the Nullarbor and the Eucla. From north to south, these are all drainage systems, and they are the Carey, Rayside, Rebecca, Roe, Lefroy, and Cowan. I put Cowan in brackets because there's some mixed evidence on whether or not it should be a separate drainage system, or if it's a tributary trunk of this Lefroy system, or it is separate now, or isn't it? I will go into a bit more right towards the end of this. But these chains of salt lakes are the surface expression of buried drainage systems. And we've known that they are the surface expression of these river systems since about 1897. And it's pretty important to remember when we're looking at these that they are not flowing down towards the south and towards the Bremer Basin. They are actually flowing north and then east. And that's important when looking at the provenance of placer gold that is found within these drainage systems. And zooming in onto the location then, we're about 650 kilometres east of Perth, centred around Lake Lefroy, about 60 kilometres south of Kalgoorlie. As you can see, this is an absolutely huge catchment. The part of it that I'm working on comprises of Lake Lefroy, Lake Randall, Dog Lake, Angelfish Lake, and these salt pans here that for the purposes of this I've called Fitzgerald Lagoon and Madunia Breakaways. The majority of the data that I'm working with is subsurface, and it's thanks to St Ives Gold Mine and Goldfields Australia that I have access to that. And that drilling I've divided into 3 main areas: Invincible, Neptune, and Sal. But as I go through this, I may call it the JV or Lex. And the other main area that I've been working in is Randall here. This is an outcrop, and all of these here are outcrops. Everything else is subsurface. I'd say maybe only about 5% of what I'm working on isn't subsurface. And a little bit of a fun fact, Japan actually white balanced their satellites against Lake Lefroy because it is so bright against the surrounding desert. But why paleochannels? Well, they're filled with gold, and they've been exploited for this alluvial gold for hundreds of years. There is supergene gold within these drainage systems, but when I'm talking about the gold, I purely mean alluvial primary places with no evidence of supergene alteration. And it's been exploited from places like Neptune, Higginsville, Lady Bountiful, Canalna, and Canolpi. These are all from Neptune. And this block here, my very first time in an open pit, Neptune open pit, I sat myself down on sort of a bank of quartz ready to sketch the pit wall. I looked at my foot, and that is what my foot was stood on. And I was absolutely blown away that there's these huge nuggets in the base of the open pit. They didn't let me keep it. That went into the gold fridge in the open pits offices, but it was a really cool memory. But we need to work out how old these systems are and how old the Lefroy drainage system is. The short answer is we don't really know how old it is. The longer answer is they were probably scoured out in the Permian by ice. But do we actually know that it was Permian? So we know that there's a lot of glacial material on the Yilgarn that is attributed to the Patterson Formation. But really, the Patterson Formation has just become a wastebasket formation. Anything that has any remote affinity with a glacial sediment is being thrown into this Patterson Formation. And no one, as far as I can tell, and I've worked on this a lot, has done any dating on it. There's some palynological studies, Backhouse 1978, did some that suggested that the material above one of these sort of tillites from further north near, I think it was near Lancefield, probably had Permian polynomorphs in it. But when he went back to his own work a bit later, he said it was just undifferentiated Mesozoic. But they must all be Permian because we know that we have a Permian glaciation has persisted. But either way, there is some evidence for glacially influenced material within the lower reaches of the Lefroy drainage. And this material here is from Madunia breakaways. That's zoomed in on that Fitzgerald Lagoon and Madunia breakaways. And what we have is a coarsening up sequence of fluvial glacial sandstone. We know that at some point this was influenced by ice because there's those classic triangular bullet-shaped sort of forms. There's some striations, there's some facets. And there's some boulders on the surface as well. Some of them are sort of half the size of me, and they are a garnet-bearing leucogranite. And the closest known source of this garnet-bearing leucogranite is the Albany Fraser origin. So we know that this is a fairly distal source. When we look at the DEM data for the drainage systems, we see things like very abrupt closures in headwaters, and we see over-deepening. So these drainages probably were scoured by ice. There's no direct dating evidence within the Lefroy drainage system. Further north, excuse me, we do have some direct dating evidence. Some direct evidence of ice, sorry. We have things like bedrock striations and polished pavements, but nothing here further south below that Menzies line. So was it a Permian glaciation? It was a glaciation, I think, that scoured these systems. How old it is, we don't know. I'd love to do some zircon dating on this material, but I just don't have the funds for it. If anyone else wants to come on board and wants to chuck some money at some zircon dating, please let me know. I'd love to collaborate. But whilst this is a fluvial glacial sandstone, there is more obvious dimictites and tillites. This here is from Agnew, and again, it's a goldfields core. I think if you looked out of the window during this glaciation, you would have seen something like this. You would have had these fluvial glacial outwash streams. You would have had a retreating glacier. And the Officer Basin would have been probably marine open ocean. There is some evidence for marine glacial sedimentation and ice rafted debris further out if we're looking at this being deposited in front of a retreating glacier. In front of it, there is some evidence for marine sedimentation. So if we sum up the influences on incision, we have ice scouring, which carved these huge valleys, and that's all happening pre-Mesozoic, we think. In the Mesozoic, we don't really have a lot of evidence for anything that's happening on the Yilgarn or within these drainages. There's a small pocket right in the southwest corner of Cretaceous sediments, and near Ora Banda, there is an impact crater that has some Cretaceous sediments in it, excuse me, that have been dated by palynology, and we know that there's probably some warm, wet, humid conditions. And there is some Jurassic duracrust, dated as Jurassic, that has been found on the Yilgarn, but there's probably some sort of erosional regime. And then all of a sudden, when we hit the middle late Eocene, we have a depositional regime. And that's what is preserved in these channels today, and that's what I'm going to be talking about. And then at the end of the Eocene, we have a sudden onset of aridity, probably related to the final separation between Australia and Antarctica. The Antarctic circumpolar current kicked in, that led to permanent ice sheet growth on Antarctica. And then we had this aridity on the Australian continent. There have been some authors that have suggested that actually that onset of aridity was during a quaternary glaciation, but I believe there's just too much sedimentation that's happened on top of these Eocene channels for it all to have happened during the quaternary. This is a quick overview then of those channels. There's three main formations that I'm working in: North Royal Formation, which is the one that is gold bearing, Werrellup Formation, and the Palinop Formation. Anyone that's worked on these on mine sites would have been calling the North Royal Formation the Padinga Formation, Hampton Sandstone, or Lower Werrellup. 2003, Jonathan Clark decided that he would overhaul all of the nomenclature, correlate it all, because these sediments stretch from Wapple all the way through to the St. Vincent Basin. It's the largest onshore Cenozoic succession globally, about 3,000 kilometers laterally. And so everything now is correlated and all of the names match, and it's all amazing because it makes things much easier for researchers. But within the Lefroy drainage system, this is an idealized section. The channels are not uniform. They're up to 120 meters deep, but that's probably the deepest. We're averaging about 60 meters for a channel in drill core. And these units vary in thickness spatially and temporally, and it's an absolute mess. Everything is interfingering with something else, and it's a headache, and we're trying to figure out what's going on at the moment so we can publish it. But let's go into these in a bit more detail then. So the North Royal Formation, that's that basal gravel. It's a coarse-grained angular quartz gravel. It was deposited in a very high-energy environment. These are high-energy bed loads and are stacked gravel channels that are happening in an anastomosing river. There's a small amount of lignite that's come in here, and we have dated it. We're sitting sort of lower middle Nophagidites asperus spore pollen zone, so that's giving us a date of about 40 to 38 million years ago. Nophagus are southern beech trees. So yeah, it's gold bearing, it's nice clean quartz, it's angular, high energy. Not really much more to say about it. I personally think this is the most boring channel sediment there, but everyone on a mine site would disagree because this is the one that's got the gold in it. But as part of this, I found a new member. I've termed it the Mount Monger conglomerate member because it was found in that Lex area, and that's Mount Monger station. It's spatially equivalent to that North Royal Formation, but as you can see, it looks completely different. Rather than being that really nice, clean, angular quartz, it's polymictic, and it's sort of got this dark carbonaceous mud that is supporting all of these larger clasts. It's dated at exactly the same age. It's obviously not as mature. It has some really large angular chunks of quartz in there, but it also has these nice water-worn, smoother chunks. There's lithics in there as well. It's really widespread in that whole JV area. It was hitting all of the AC holes as well as the diamond holes. Why? What's going on? Why isn't it as mature? Is it a different source? Is it a different drainage catchment that's not always as active? Is it higher up in the paleotopography? Is there some sort of near tectonic happening there? Probably, but this is something that I haven't been concentrating on because all of the fossils have been way more interesting. So these questions have to be answered as part of the ongoing research. And there is some minor gold found in these basal Mount Monger conglomerate, but whether it was a result of contamination or smearing, the geologists can't tell me, but there is some gold there. And then sitting either conformably or unconformably, depending on where you are in the system, you have the Werrellup Formation. This is probably the thickest unit that we see within the Lefroy drainage system. In some holes, we're getting 60, 70, 80 meters of this, and it is a change to very low energy conditions. This is an alluvial plain, a lazy, swampy, meandering river. And there's loads of fossils in it. So if you look here, this is a varved sediment. Well, I've called it varved. It's formed from suspension settling, probably an overbank flooding deposit. And it may be evidence of seasonality because we are getting those very, very fine laminations. If you get your eye in on this bit of core here, each one of those black lines is not a dirt. This isn't dirt. This is a fossil leaf. It's broad, it's flat, it's a rainforest taxa. So we're getting evidence about the climate. Nice, warm, temperate rainforest, complete opposite to what happens if I look out of the window today, where I'm seeing just red dirt desert. And fossil wood. Well, there's so much fossil wood in this system that you could be picking it out for the next 6 months and you still wouldn't get to the end of it. But you do see a lot of water-worn, nice, smooth wood fragments. The palynology in this is pretty unremarkable. It confirms all of the prior studies that were done in the early 90s. We're in that middle Nerphagidites asperus zone. But there is some marine influence in one of the drill cores in that Neptune area. At first, I thought it may have been contamination and it may have been sort of fall from above it. But knowing what I know about what I'm going to talk about in a couple of slides, I think there probably was some marine influence that comes from some sponge spicules and a braided dinoflagellate cyst. And this here, super interesting. One of the first things I looked at is a fossil fruit. There were about 20 of these found in one drill hole. They're all at GSWA in Perth at the moment. If you know what they are, please let somebody know, because I've been racking my brains for 4 years trying to find out what they are. They've been found in younger sediments elsewhere in Australia, but none from Western Australia in the middle late Eocene. We just know that it's a fossil fruit. And some more Werrellup Formation. If you get your eye in and you look, you'll see that there are some vertical columns of lignitic material here, truncated by this grey clay layer. This is a drowned forest. These are all trees up in their life position, and they have been flooded out by this clay. This is also seen in other pits. It's not just seen in Neptune. It's been seen in the Princess Royal pit in Higginsville, but those trees were ferruginized. These, as you can see, aren't. I'm willing to bet that if we looked at other paleochannel pits throughout the Eastern Goldfields, we'd see this in most of them. However, these pits flood. These drainage systems are still very much active today, but only subsurface, unless there's been a large rainfall event. So unless you're constantly pumping the water out, these pits are going to flood. If you're working in one of these open pits and you see something like this, please document it. Take photos, quick location, let me know, let someone else know, so we can save this data, because it does give us a really good insight as to what the environment was like during the Middle Late Eocene and the Yilgarn. And then we have something else a bit weird happening in the Werrellup Formation. We're back to a higher energy environment. And this is a cross-bedded clastic sandstone with some rip-up clasts in it. It's only been found in maybe 2 holes. Called it a very spatially inconsistent progradational delta. We do know that there is it's probably tidally controlled. We know that there is marine that is deposited on top of the Werrellup Formation. There is some cross-bedding in it, but unfortunately, there's no economic value in running a tool down a hole for paleochannel sediments, especially towards the top of them. So we don't actually have the direction on that. But what we can see is we've got this lovely low energy lignite and clay here. And then there are rip-up clasts of this clay in the start of this. So we're seeing that transition from lower energy to higher energy with those rip-up clasts. They're intraformational rip-up clasts. And then we have this cross-bedded sandstone here. And this is what it looks like in cross-section. There's no known marginal marine fossils in this. However, knowing what I know now about another formation that I found as part of this research, I would probably go back and look at this core and check it for some marginal marine fossils and see if what we're seeing is actually a grade into the Palanup Formation. So some more work is needed, and luckily this core is stored at Geological in Kalgoorlie, so I can go and annoy them and ask them to get it out for me for about the 7th time in the last 5 years. And then as part of this, I found another new member. I've termed this the Lake Randall Spiculite member. It's another weird one that is exclusive just to that JV Lex Sow area. It's up to 55 meters of lignitic silts that are full of sponge spicules. Sponge spicules are just the broken, abraded bits of sponge, basically. Their bodies form from all of these spicules, and here they're siliceous spicules, so they're like glass. If you work with this and you touch it without gloves on, you'll know about it because you'll be picking essentially glass shards out of your hand for days and days. But it's weird because we're seeing 55 meters of this marine influenced lignitic material. And it's definitely marine because we're in a dinoflagellate zone, and it's the Tekecha transgression, which is what we see deposited on top of the Werrellup Formation. But this isn't a fully marine sediment. It's probably some sort of backwater lagoon, definitely proximal to the coastline. I think maybe something like the Fitzgerald Inlet. If you've ever been in Fitzgerald River National Park, you've been to the Fitzgerald Inlet, you'll know that there's that very, very narrow opening to the sea after heavy rains. Otherwise, it's just a happy little backwater sort of swamp. So we're not quite sure what's going on, but the other really interesting thing here, and if you get your eye in, you'll see there's all of these silver bands up and down the core at irregular intervals. It's all marcasite. Well, marcasite replacement isn't rare within the Lefroy drainage system. I have some huge pieces of tree and bark and twigs, and if you've ever seen me in person, I always bring these with me when I talk about this because they're absolutely amazing. Lignite that has been completely replaced by marcasite. But here, it's not really replacing anything. And we had to think about it, and we think it actually is replacing something. We think it's replacing dinoflagellate blooms and evidence of seasonality in this unit. However, we can't really do anything to prove this because it means destroying the whole core. And mine sites don't really like giving up core that they've paid for. What we would have to do, because as you can see, this is really, really fragile. It's not lithified. You sneeze and the whole thing collapses. We would have to stabilize the core first with paraloid. We would have to completely turn the whole thing solid with paraloid, which is a type of resin. Sometimes rocks are impregnated with paraloid so that you can make thin sections, but we'd have to do it for this whole core. Then we'd have to wait for it to cure, and then we'd have to take thin sections all the way up and down this core to check to see if these are dinoflagellate blooms. I'd really love to do that. It has been seen elsewhere, places like the Gulf of Mexico, you can see these, and it's evidence of seasonality. I'm just gonna, keep it as a hope and a dream in the back of my mind that probably is some sort of evidence of seasonality that we're seeing there. And then this right here is the block of fossils that Dave Nixon asked me if I wanted to have a look at. And yeah, they're definitely fossils. There's no sun-addled brain going on there. This is the Palanup Formation. A Palanup Formation is really, really extensive on the southern coast of Western Australia. It outcrops all the way from Wapple, all the way through to Esperance. It's a glauconitic sandstone. But here within the Lefroy drainage system, it's found in Neptune open pit. These two blocks are from the Neptune open pit. And this is some core from the Invincible drilling area. It's only found in those places. And quite interestingly, where it's found, there's a fairly strict profile below it. There's either no or a very weakly developed saprolite with this deposited on top, and sometimes a very thin veneer of the Werrellup Formation. And there's never any North Royal Formation. So why? Is it occurring at paleotopographic highs, and these are then not being eroded when subsequent high stand sediments are being deposited? Very likely. But this is pretty special to find in the middle of an open pit on the Yilgarn. So within there, we have there's polished ferruginous gravel in there. There's lots of very poorly preserved fossils. They're all replaced by glauconite, whether they're macrofossils or microfossils. It's a very, very high energy, shallow marine environment. There's some very coarse grained sands in there, and they're a mixed maturity. There's some beautiful rounded grains, and there's some really, really angular grains. There's polymictic lithic fragments in there as well of that same mixed maturity. I think it's a mixture of high energy and reworking. And because there's quite a lot in here that's been ferruginized, I think there was probably some sort of drying event that exposed this. And because it's at a paleotopographic high, it was exposed and then it was subsequently buried during that high stand event. And the forms of these macrofossils do let us know that it was a very high energy environment. These are deeply ribbed pectins, free swimming. But the microfossils let us know that this was actually a really healthy marine environment at very normal marine salinities. These are benthic foraminifera here. There's a gastropod world. There's some echinoid spines in there. There's nothing in there that's letting us know that this is a stressed community at all. There's nothing in there letting us know that these aren't normal marine salinities. It's just a classic marine environment. And these are some SEM images of those microfossils. When you look at them, they look really, really poorly preserved. They look really acid etched. They haven't been processed using acid. We don't need to. This material isn't lithified. It's just been sieved with water. But that acid etching is a result of those percolating waters through these drainage systems subsurface. The pH in those is down to about 2.4%, and the salinity is up to about 26%. So that's probably why these look so awful and they look so acid etched. And it's probably why we have a lack of vertebrate evidence as well. There's no fish teeth, there's no fish scales, there's no bones or anything like that. But yep, these are echinoid spines here, some foraminifera, and that's a little gastropod there. So I personally think these are really beautiful, even though they look really acid etched. And as a micropaleontologist, yeah, it's pretty special getting to work on these and knowing that you're the first person to work on them and you're the first person to ever look at these under an SEM. Not that the SEM images are telling us anything, because they are so recrystallized and acid etched, it's actually easier to identify them down to species using refracted light. And the most common unit we see is the Princess Royal spongylite member of the Palinop Formation. This is hit in nearly every single hole, and it's what we're finding in outcrop. I've not found anything else in outcrop. It's all just been this Princess Royal spongylite member. And I've divided it into two fascies. There's a channel sandstone and there's a shoreface deposit. This is being deposited at the high stand of that To Catch a Transgression. You notice I've said it's not deep and it's not cold. Where we're seeing fairly thick spiculite mats in modern environments and in the rock record, we're seeing them in dark, deep, cold polar waters. And maybe 30 or 40 centimeters thick. Here, within the Lefroy drainage system, we're getting 20-25 meters of thick trough cross-bedded spiculitic sandstones. And it's deposited in very warm and very shallow water. We know this because of the mineral odonite has been found in here. That only occurs where sea surface temperatures go over 20 degrees Celsius and in depths of about 60 meters or up to 60 meters. And we know there's diatom in there called arachnodiscus and berghain, and that is only found in tropical waters associated with mangroves and seagrasses. This is zooming in on some of those channel sands. So they're up to about 90% spicules. Deposited proximal to a marine setting, probably tidal inlets. And you can see, I just go backwards and forwards, that's another image of the pit wall there at Neptune, and you can see the trough cross bedding in that. The spicules in there are a very complex assemblage. I'm not a sponge spicule expert by any means, but I'm lucky enough to have a couple of colleagues that are. One of them actually did her PhD on the sponge spicule assemblage of a correlatable unit in South Australia. So they have lots of material at the moment from this, and they are working on it, and hopefully we're going to be able to publish it and let the world know about that amazing assemblage and what it's telling us about the paleo environment. So we also have this shore face or beach fascies. It's spiculatic, it's quartz in there as well, and it's very, very round quartz. If you've ever been to the beach, Esperance, Albany, any of those sort of south coast beaches, and you've stood and you've done the little shimmy and twist and it squeaks, it's squeaking because it's got the quartz is really, really rounded, and that's exactly what's happening here. Although I wouldn't want to do it in the late Eocene because my feet would be filled with glass spicule splinters. But you can also see, you know, any beach you go to, when you see the waves washing up on shore, you'll notice that they're winnowing black minerals. That's pretty much what's happening here that you can see there. You can also see it in the outcrop too. Just some miscellaneous features of that Princess Royal Spongylite. We know that this is being deposited in really high energy conditions, either shore face or near shore. We know because we've got these ophiomorpha burrows. This is the first time these have been found on the Yilgarn Craton. There's just a thin section image of that diatom there. Some cross bedding in the Binnaringi outcrop. The Binnaringi outcrop is a little bit weird. Not 100% sure what's going on because we have these ophiomorpha burrows. I don't know what would want to live in what is essentially crushed glass, but these little crustaceans were. And then on top, we have these absolutely huge trough cross sets. So just going through some other images, just because I couldn't resist putting in more field photos. This is just some perfect channel architecture here. This is from the Fitzgerald Lagoon locality. Weren't expecting to see this. It's not marked on any of the maps. And then we got there and we saw that, and we had to climb up, and it was spiculatic. So that was pretty cool. And there were 3 or 4 of these channels that we could see coming in with this perfect channel architecture into this one salt pan. This boulder here fell from another one of those channels. You can see there's some rip-up clasts in there as well. So we're seeing that change from a lower to a high energy environment within this. We could be seeing the base of a transgressive event within this channel. And then here, I don't know if the image quality is going to be good enough for you to see, but you can see there's some sort of segmented tubular worm type things. And these over here, probably some sponge fossils sat in there as well. A lump of this has also gone to Poland to my colleagues. We're not really sure where this is fitting. No one was expecting it to find it where it was. So it's really interesting and it's really exciting because we're finding it there, but where it fits in the model spatially, we're not quite sure. That's something that I've actually this week been trying to figure out. But probably the most exciting part of this is finding this. This is the Fitzgerald member or Fitzgerald member equivalent. I've told this story heaps. I found this by accident. I was having an absolute tantrum in the field. My poor fieldy Oleg that had come out with me was probably sick to death of me moaning. This was maybe the 3rd or 4th weekend that we'd gone out to this one outcrop. And on the geological map from the 1960s, it was labelled as a limestone. And I'm thinking, yeah, let's go look for it. Limestone, wow, bet no one's worked on that before. Couldn't find anything. There's no limestone out there. But I threw a tantrum and I threw my bag down and I threw my hammer down and I stormed off and I sat down on a little ledge of rock on the edge of this salt pan. And I looked down and I saw this. Now, if you might have to get closer to the screen to see it, but each one of these is a sponge fossil. And then when I looked around, there's more sponge fossils and there were more sponge fossils. And about 20 meters, maybe even a little bit more than that, along strike and about 3 meters high, we had this reef made up of just sponge bodies. Within the Palinut Formation, this isn't actually rare, but this has never been found on the Yilgarn before. These are completely novel to the Lefroy drainage system, possibly even novel to science. lots of samples of these have gone to Poland. And then there's also some calcareous macrofossils. You can just see a couple of them there. That was really cool. Yeah, so this is what I'm working on at the moment. And then there's some more. So these are all siliceous sponges. There's lithicid and non-lithicid demosponges. So the closest known affinity of this is the Fitzgerald River Formation, or member that outcrops near the top of the Palanup Formation on the southern coast of Stirling Ranges, Fitzgerald River National Park. It's never been found here before. So what this is telling us is either we've had more epeirogenic uplift than we thought, or the high stand of these of this to catch a transgression was much higher in sea level rise than we previously thought, or probably a combination of both. Prior authors suggested that we could never get this sort of shallow marine environment where we found it because the sea level rise wasn't high enough, but it's definitely there and we found it. And these are all being deposited at normal marine salinities. It's not a stressed community despite it being dominated by sponges. There are those rare calcareous fossils in there, and there are some diatoms too. And I do like giving modern equivalents and modern analogies. So that's just my kids there, my two eldest, and they're at, I think that's Twilight Bay, might be Lucky Bay, but I'm pretty sure it's Twilight Bay, Esperance. And if you looked out of your window during the late Eocene, you might have been stood on top of Red Hill in Kambalda, and all the way around you, you would have seen this. All of those high hills that we see, Peak Charles, Peak Eleanora, Mount Burgess, Mount Charlotte, Red Hill, they all would have been sticking out loud and proud little islands, and we would have had this shallow sea. Probably no good for a swim because it is basically crushed glass. And then we have that change to aridity. Colloquially, we call these lake sediments. They're the post-Eocene Royce Salt and Revenge formations. Paleologically, what's been pulled out is just undifferentiated Cenozoic, but there's definitely scope to look at this and look at these Holocene sediments and understand changes in climate and rainfall and rates of flooding events within the Lefroy catchment. Doesn't interest me. If anyone else wants to do it, I've got loads of samples if you want them. But fluvial flow through here, modern flow is pluvially activated. It's activated by rainfall. There's no permanent standing water at the surface. Although I have posted a couple of images and videos on my LinkedIn page the last couple of weeks. We had more rain across 48 hours than we normally get in a year. And all of these channels just completely came to life and flooded, and it was amazing. So summing up that sequence, then we've got high energy stacked channels with the golden, then we've got lazy meandering rivers, and then we have this marine to catch a transgression in there. Then we have a little bit of a controversy. We have the Norseman limestone. Is it or isn't it? I'm willing to bet that this is the first and only image of a coccolithophore from the Yilgarn Craton. Found it quite by accident. I was SEMing some chunks of bryozoan, and my supervisor was behind my shoulder and went, zoom in on that. What's that there? And we zoomed in, and every time we zoomed in, it became more and more clear that there's a little coccolithophore there. So this is a legacy sample that my husband discovered by accident. He was browsing the GSWA DMP and noticed they'd done an upload of old reports. And this one's from the 70s. And it says it's a Norseman limestone formation from a borehole on Lake Lefroy. But is it? Or is it mislabeled? Has it come from Lake Cowan? So it's a coarse-grained bryozoan limestone packstone. It's beautiful. It's got all of these amazing microfossils in it. It's got different forms of bryozoan in there. And under SEM, we've got this beautiful, I think this is beautiful, despite this having probably the worst day of its life. This is it in cross section, and it's all abraded around the edge. But this is a Sherbernina atkinsoni, and you can see all of that amazing chamber structure in there. So I think it's absolutely amazing. But is it Norseman limestone, and did it come from Lake Lefroy? So I've spent quite a lot of time in the dusty archives at Lefroy at St Ives Gold Mine, looking for the original log from the borehole that this supposedly came from. I've looked at all of the original KNO grid maps. I can't find any mention of it. I've been in Waymex looking for this hole. Can't find any mention of it from either Lefroy or from Lake Cowan. But the report along with this sample says that it is the first known inference of Norseman limestone from underneath Lake Lefroy. And if it is from Lake Lefroy, so where it's found now is where the Revenge waste dump is, if anyone is familiar with Lake Lefroy. John Clark, when he worked on all of this initially in the 90s, and I'm building on his amazing earlier work, suggested that the Cowan system had to have become separate from the Lefroy system prior to the Middle Eocene and the deposition of the Norseman limestone, because it is found within the Cowan system, but it hasn't been found from Lake Lefroy. And the Tortuccia transgression event that deposited this didn't have enough sea level rise to flood the Lefroy system through the Eucla Basin and from the east. It had to have flooded up from the Bremer Basin and into Lake Cowan. So that's why we see it here in Lake Cowan, but not here in Lake Lefroy. He mentioned that this may be to do with the Jarrowwood axis. Now, the Jarrowwood axis is a hinge line on the Yilgarn, down warping. So the southern part of the Yilgarn is down warping along this Jarrowwood axis, all to do with aporogenic uplift. Previous authors have suggested that actually, no, we shouldn't put the Jarrowwood axis where John Clark has put it. It has to go further south because we have to allow the Cowan system to be a tributary trunk of the Lefroy. But it seemed to have been settled when we didn't find Norseman limestone underneath Lake Lefroy, but we found it underneath Lake Cowan. However, if this is Norseman limestone and it has been found from Lake Lefroy, we have to put that Jarrowwood axis lower south of Norseman as opposed to north of Norseman. We probably have to say, yes, these systems were one and the Cowan is just a tributary trunk of the Lefroy. So this completely changes our understanding of system evolution and paleogeography during the Middle Late Eocene. I think it probably was mislabeled, but it's nice to have a story and it's nice to think about it. And also that's the first time anyone's worked on sort of the systematic paleontology of that Norseman limestone. We do have some wave cut platforms, though, that are related to this transgression event. Mount Ragged, Peak Charles, Peak Eleonora, and even the hollow of Frenchman's Peak is suggested to have been hollowed out by waves during this transgression event. So that stratigraphy is really locally far more complex than previous work has suggested. There's a very, very complex interfingering of terrestrial, marginal marine and marine environments. We definitely can't use this nice stylized log. We're going to have to put lots of little interfingers in here. We know that those onshore Eucla marine sediments then and marine environments were far more reaching than anyone has previously estimated. And that Fitzgerald member equivalent is present, and that's really, really exciting. What's next? Well, we're going to publish all of this data, and there is a lot of it. I've spent the last probably almost 6 years now gathering data. We're preparing 2 publications at the moment for submission. I'd love to do some zircon dating, especially on that glacial sequence. So if anyone's got any funding, hit me up. We need to refine that paleogeography. And I need to keep describing that novel microfauna assemblage. And I'm also going to keep looking for outcrops. I'm really, really privileged that I live here in the middle of nowhere, right on top of my field area, because I can go out for a jolly on the weekends around these salt pans and I can look for more outcrops. My kids are getting a little bit older now and they don't want to do that anymore, but that's okay. It gets them some fresh air. But where did that Lefroy gold come from? This is where I either get told to hand back my degree or I make people go, So looking at the geochemistry of this alluvial gold, about 95% of it is coming from the underlying gold camps. However, there's about 5% of grains that are not related to the underlying camps. They have come from a much more distal source, and geochemically, they don't match anything that we know. This quartz, alluvial gold-bearing quartz, is common in all of these drainages south of the Menzies line. Something big had to have occurred to have this uniform deposition in middle late Eocene sediments in the base of these paleochannels. I think maybe ice put it there, and ice has brought it. This glaciation, I think, has brought in rocks from a much more distal source, and through fluvial environments and weathering, that gold has been winnowed and left there in the base of these channels. And there is evidence for this elsewhere. We're mining gold like this elsewhere. Canada, Southeast Andes, Otago, they are mining glacially winnowed and deposited alluvial gold. So just a little bit of food for thought. If it hasn't come from the underlying camp and we know it's come from a more distal source, how did it get there? I've got loads and loads of people to thank. I've got Espen, Paul, and Greg, who are my very long suffering supervisors. Goldfields Australia, who have let me have lots of access to their core. Sarah, Alicia, and Hugh at GSWA, who I've bothered a lot with questions. I've used Oleg, Ben, Leo, and Jay as my fieldies. They have all either worked for or are still with Goldfields Australia. Andrzej and Magdalena, who are my colleagues in Poland. Andrew Rosefields and Ray Carpenter, who are paleobotanists, absolutely amazing. Adam Charles at MG Paleo, who does all of my palynology work for me because no one will let me play with hydrofluoric acid at home. And all of the Argonauts, all of the people in the Australian Regolith Geoscience Alliance, but especially Anna, John, Nadir, and Nacho. They've all been phenomenal supports to me, and I'm really grateful to have them as mentors and as supports. But also my kids. I need to thank my kids because for the last 6 years, they put up with me flying all over Australia for different things. I hide in my office a lot with my microscopes, and I do nothing but talk about rocks. And their dad is also a geologist, so they've really got no hope. And they've also been absolutely amazing fieldies. They've joined me on lots of bush bashing adventures, and now they're getting really good at identifying rocks. One of them actually wants to be a paleontologist. This one here, Rosie, my middle kid, she wants to be a paleontologist herself. So thank you very much for having me, Jess. And that's the end there.
You are fantastic. Thank you so much. That was so well presented. I really, really loved that.